In this video, we're going to look at solving quadratic equations by taking square roots. So we've talked about how to solve them by factoring or using the zero product principle. Now we're going to look at solving by taking square roots. So let's consider these two equations. X squared equals 9 and x equals the square root of 9. To some people, they may appear to be the same, but they're actually asking slightly different questions. The first one's asking what numbers or whose square is equal to 9? What number square is equal to 9? Where the second one's just asking what is the square root of 9? In both cases, we see that a number you square to get 9 is 3, and the square root of 9 is 3. But if we consider the first case, x squared equals 9, there's another number that whose square is 9, and that is negative 3. That doesn't show up in the second problem. In order for us to get this negative 3 as an answer, we would have to consider the problem x equals negative square root of 9, or what is the opposite of the square root of 9, and that would be negative 3. Square roots give you positive answers as a result, and so if you want to get a negative answer, if you want to consider, well, what if it's positive or negative, you're going to have to institute that negative sign into the problem. It's not going to be there maybe naturally. So that's going to be a key thing when you're doing these problems. You want to get all the answers, you have to consider the situation. When you start with a square statement, that it could be positive and negative involved. So let's look at some problems and kind of look at the advantage of taking square root. So let's say I have this. In that previous example, I could have subtracted the 9 over and did the difference of squares and found 3 and negative 3. But this would not factor if I brought the 12 over. 12 is not a perfect square. So by taking square roots of both sides, so you think about what's the opposite of squaring something, it would be square rooting it. And again, I have to consider that this could be a positive number or a negative number. So I need to put this in here. This way, plus or minus is how we usually say that. And then I'm going to break this down. Square root of 12 is square root of 4 times square root of 3. Square root of 4 is 2, so plus or minus 2 square root of 3. What this is saying is the two answers we got were positive square root of 3 and negative 2 square root of 3. So those are the two answers we can get, and these are non-rational numbers. We couldn't get those by factoring, typically how we would normally consider factoring, but we can get it by taking roots. So let's consider this slightly more complicated problem. So again, I got a square here. I don't want to multiply this out. What I want to do is I want to peel the layers off the x. I want to get rid of the square. I want to get rid of the 3, and then I want to get rid of the coefficient of 2. And so to get rid of the square, I'm going to take the square root of both sides. Again, taking into account that I could have a positive and negative involved here. So on the left-hand side, the square and the square root cancel out. You get 2x minus 3. On the right-hand side, I get plus or minus 5. And now I'm going to solve this for x. So I'm going to add 3 to both sides. Now that doesn't give me plus or minus 8. That is 3 adding to 5 and 3 subtracting to 5. So this is how I would normally write it. But if it helps you understand, you can write that in two separate statements. So 3 plus 5, 3 minus 5. Now what I'm going to do is I'm going to maybe clean that up a little bit. And 3 plus 5 is 8. And totally separate, 3 minus 5 is negative 2. So these are what my two answers are going to be based on. Then I'm going to divide by that coefficient of 2. And I'm going to get 4 and negative 1. So notice, it's not just 4 and negative 4. These are two different answers. The plus or minus comes into play when you do the square root. You can't forget to do it then and then just kind of throw it on at the end. It's got to come in when you do that. Now let's look at this one. So the first thing I need to do is isolate that root. So I need to get rid of that 4. So I'm going to subtract 4 from both sides. Then to get rid of the square, again, I'm going to square root. That's, the square and the square root are going to cancel out on the left-hand side. 2x minus 3 equals plus or minus square root of 20 is 4 times 5. Square root of 4 is 2. Square root of 5. And now I'm going to add that 3 over. And I'm going to put it in front of there. Sometimes people might want to put it behind the root part, but I put it in front there. Now you might be tempted, oh, is that 2 plus 3 and then root 5? No, that's 3 plus 2 root 5. Those are not like terms. The 2 has a root 5 attached to it. The 3 does not. So they are not like like terms. You can't add the 3 and the 2, then do the root. It's 3 plus 2 root 5, 3 minus 2 root 5. So got to keep them separated. And I need to get rid of that coefficient on my x, so I'm going to divide both sides by 2. Now I could leave this as a single fractional statement like this, or if I chose to, I could split this into 2 fractions, 3 over 2 plus or minus 2 root 5 over 2. And if I did that, you'd notice the 2 in front of the root 5 would cancel out, but the 3 would still be over 2. If for some reason you thought that was a nicer way to write the answer, you could do that. Either one of these answers is okay. So we can see that this root stuff can help us deal with rational numbers, real numbers, irrational numbers. What else can it deal with? What about if we look at a problem like this? What number do I square and get negative 16? Well, a negative 4 and a negative 4 make a positive 16, a positive 4 and a positive 4 make a positive 16. Within the real numbers, this doesn't work, but I can find this doing roots. So I take the square root of both sides, again, plus or minus. Don't forget the plus or minus. And then square root of x squared is just x equals plus or minus the square root of negative 16 is 4i, that imaginary unit. So I can get non-real answers here as well. And so looking at a more complicated problem, again, the first thing I want to do is get that square apart by itself, get rid of the 34, so subtract 34 from both sides, giving you negative 24 on the other side. And then I want to get rid of that square, so I'm going to square root both sides again, putting that plus or minus on the right-hand side, and simplify it. So on the left-hand side, the square and the square root cancel each other out, leaving you 2x minus 5, plus or minus square root of negative 24, well, that's 4 times 6, so 2, you got a negative, so an I, root 6, and then I'm going to solve this just like before. I'm going to add 5, I'm going to divide by 2. In this case, I cannot leave this as a single fraction. Because there's an I involved, I have to split this up into 2 fractions. The first one's going to be 5 over 2, which isn't going to reduce, plus or minus 2i root 6 over 2, and those 2's on the outside, the 2i and the 2, those are going to cancel out, giving you I root 6. I have to split those up when there's an I involved. That's why when there's not an I involved, I still would recommend you split them up, just to get in the habit of it, so that when it does matter, you don't need to remember to do it. Alright, thank you, and this is our introduction to solving by square roots. We will look at how to write expressions in this format if they do not start this way in the future.